Hello students, today I am going to discuss with you the chemical equations. So as you know, there are so many chemical reactions as when magnesium is burned in the presence of oxygen, then magnesium oxide is formed. In the same way, when sodium hydroxide is treated with hydrochloric acid, the neutralization of both acid and base will take place, and the sodium chloride and water will be formed in this reaction. So, do you know how to describe a chemical reaction? So, as I am telling you the description of the chemical reaction, so this is the language. This is the language method to describe a chemical reaction. As I have told you, when magnesium is burned in the presence of oxygen, so magnesium oxide is formed. Again, to make it short, to describe a chemical reaction, we can take the help of words. We can write magnesium, oxygen, then magnesium oxide. So magnesium and oxygen he reacts to give the magnesium oxide. This shows in the same way the word method sodium hydroxide, hydrochloric acid react with each other, then sodium chloride and other. But to find another shorter way to describe the chemical reaction, we will use here the language of chemistry. Here you need to learn the language of chemistry. As I have told you in my previous video, that the formulation symbols, that how will you make the formula of different chemical compounds or the symbols. So please learn the formulation of the different chemical compound from my previous video. Now you can write here again the magnesium. You can a symbol of magnesium. You can write oxygen O2 and magnesium oxide is formed. In the same way, sodium hydroxide reacts with HCl, then there is NaCl and H2. This is the again shorter way. So, how will you find a way in that the chemical reaction may be described in a shorter way? This is to describe the chemical reaction in the shorter way is the chemical equation. So the chemical equation is a icon or a symbolized form of a chemical reaction. And it is also called a shorter way to describe the chemical reaction. So now come to I will tell you the format. The compounds that take parts or that undergo the changes are called as reactants. And after completing the reaction, the newly formed compound are called products. So this is the format of the chemical reaction. First, in the left hand side we will write the reactants, and on the right side we will write the products. So again in the last phase we are balancing of the chemical equation. So as I told you, to describe a chemical reaction, the first method may be language, but it is very a large method, time consuming method. Then we will come to the word method. Lastly, we use the chemical language or the language of chemistry, that the formulation, symbols and formulas of the. So your duty to learn first the formulation, then you will able to write the chemical equation. So these are the format. Again in the last I will tell you about the balancing of the equation. All the chemical equations should be balanced. So step by step, first I will tell you about the format. and then I will tell you about the balancing of the chemical reaction. So what is the format of the skeleton or the format of a chemical reaction? As I explained you that on the left hand side we will write here reactants, and here these are the products. So reactants and products are combined with a arrow with towards the right side. So these are the reactants. Suppose when the two or more than two reactants are there in a chemical reaction, all the reactants or the products will be written with a sign of plus, or we will write a sign. Suppose here we are giving you when magnesium is heated in the presence of oxygen, so magnesium and oxygen are written with the sign of plus. We will place a sign of plus between two reactants or between the two products. So here the only one reactant is there. So here the one MgO. And here, so in the same case you can write here, suppose NaOH, sodium hydroxide plus HCl, and we'll write here NaCl plus H2O. This is the skeleton. This is the skeleton of chemical equations. This is the skeleton of the chemical equation. Now I am explaining more about the skeleton. If there are, do you want to tell the state of the reactants or the products? So we can write here for the solids, we can write here S. Suppose here this magnesium is solid, we can write here S. Suppose solid and liquid, so we can show with the help of L in a bracket, small l in a bracket, that it is, so this L, it is the NaOH is in the form of solution or a liquid. This O2 is in the form of a gas, and this HCl, suppose this is also in the form of gas, or you can say in the solution, so here the liquid, and again the gas is represented by small g. Gas is represented by small c. It is solid, you can also represent it by downward arrow, and the gas you can also represent with the upward arrow. So these, when you find in a chemical reaction written as SL, and the meaning of these symbols tells us about the state of the chemical compounds or the reactants or the products. If suppose here it is as is written here, it means NaCl will be formed as in the state of solid. Here it is S2O, though S2O will be formed in the state of liquid. So this S for solid, L for liquid, and G for liquid. And again, I am telling you, there are this on the arrow we can write the temperature, pressure, and pressure, and also one thing more I am telling you, catalyst. If suppose the E is here, it is here Fe, and here 200 degrees centigrade, and 200 pressure 208 atm, atmospheric pressure. So this also shows as this reaction is taking part in the on the 200 degrees centigrade temperature, 200 atmospheric pressure, and in the presence Fe acts here as a catalyst. So this is the format. In the last I am telling you all the natural gases. All the natural gases will be written in the chemical equation in the form of N2, O2, Cl2, H2 in the molecular form. All the gases will be written in the chemical equation in the form of a molecule, or you can, I mean to say that when you need to write oxygen, so oxygen will be written in the O2, N2, Cl2, H2. This is the format or the main thing you should know before writing a chemical equation. So now I am telling you the balancing of the chemical equation. So first question arises that what is the need of, these are not the, this is balance, this is not a balance. You can write here 2Mg and 2MgO. This is a balance equation, but I am telling you the balancing of the chemical equations. Balancing. So first of all, think that what is the need to balance an equation? What is the need? As you have studied the law of mass of conservation. Law of mass of conservation. In that, what tells you the law of mass of conservation? That tells us the mass of a matter can neither be created nor be destroyed. So, when the mass of the reactants, the mass of the reactants will be equal to the mass of the products. See here you can put here the sign of equality. So you can write here equal. So here reactants is equal to products in case of mass. In case of mass, the mass of the products, mass of the product or the mass of the reactants will be equal. So according to the law of mass of conservation. So it is very difficult to know. We can suppose we can calculate the mass of magnesium, but we can't calculate the mass of oxygen. So it is very difficult to balance the equation by equating the mass, by knowing with the help of mass. But so how will you balance the equation? Suppose this is magnesium, this is oxygen. So here this is magnesium oxide. Suppose this magnesium oxide is formed here. Magnesium oxide is formed here. First of all, we will see whether we have written the symbol or the molecule or the formula of that compound is right or not. So here magnesium O, and here the magnesium oxide, you can write here magnesium oxide, so the magnesium double positive and O. So correct. Now you will action. How will you? So by counting the atoms of the reactants or the products. So all the atoms of the reactants as well as the products should be equal. So the atom here, the atom of magnesium is 1. So here atom of magnesium is 1. Here 1 magnesium. And here oxygen is 2. So you can write here. So this is the balanced equation. But the atoms of the oxygen, here oxygen one atom, here oxygen one atom. But if you write here, oh, as I told you, all the natural gases should be written, must be written in the form of a molecule. So this O should be written as O2. So this oxygen should be written as O2. So if you write here to balance the equation MgO2, suppose you convert is MgO2, so this is the wrong formula. This is not a formula. This is not the way to balance the equation. You can't change the formula of the magnesium oxide to balance in the equation. So here, what will you do? So you will put here to make it O2, you will multiply this whole equation by 2. So you will write here 2Mg plus O. This O is the 2O. 2O. 2O means O2. 2O means O2 is equal to 2MgO. 2Mg. So magnesium is here 2 and here 2 and this. This method is known as hit and trial method. To write in the examination, you will say the balancing of the equation. There are two methods to balance the chemical equation: hit and trial method. Hit and trial method. Again, I am telling you. Suppose you take here aluminium. Suppose here this is aluminium and this is oxygen, and when aluminium is heated in the presence of oxygen, aluminium oxide will be formed. So first of this is aluminium. Aluminium oxide. Now you have to think the formula of the aluminium oxide. What is the aluminium oxide? So please watch my previous video to know the formulation. So in that I am telling you very well to make the Al2O3. So the formula of the aluminium oxide is Al2O3. Now you have to balance the equation. Here the aluminium, the atom of aluminium are 2. The number of atoms of aluminium are 2. Here aluminium, so you can write here 2. Here the oxygen are 3. Here oxygen are 2. So you can write here. But in fraction, you are not authorized to write in a fraction. In fact, we can't balance the equation in a fraction number. So always this number be whole number. So here, what will you do again? So again I am telling you fact. Here you should write, first you write here aluminium, oxygen. First write to understand, to make you understand, I am writing here O. So how will you, so suppose this is aluminium, this is oxygen. So here you will write here Al2O3. Al2O3. This is Al2. So here 2Al and 3O. This is the balanced equation. So first to balance the equation, you can write all the natural gases in an atomic form because you are counting the atoms in that equations. So this is the atomic form of oxygen 2Al3O. It is Al2O3. It is a balanced equation. But as I told you that all the natural gases will be written in the molecular form. So here you have to change this 3O into O2. So multiply the whole equation with 2. Multiply the whole equation with 2. So you can write here 4Al. 4Al, 3O2 and 2Al2O3. This is the way to balance the equation. To balance the equation. Now the second method to balance the equation, First I told you the heat and trial method. Second is the partial method. Second one is partial method. Second one is partial method. Partial method. This is the partial method. In this method, suppose we take an example of an sodium chloride NaCl is treated with sulfuric acid. Sulfuric acid. So here the sodium replace the one hydrogen NaHSO4, sodium hydrogen sulfate, and this H1 H is replaced by sodium, and this H again joined by this H. So here HCl will be formed. Again, this NHS NaCl, the second molecule of NaCl, will react with sodium bisulfate to form the Na2SO4 plus HCl. This is HCl. So again, you can pass. These are the partial. The whole reaction will be, you can get the by adding these two reactions, then 2NaCl plus H2SO4. Here Na2SO4 plus 2HCl. These are the two methods to balance the equation, the chemical equation. First one is heat and trial method, and second one is partial method. But I will tell you, I will explain you the balancing of the equation in a large way, in a huge way, with the help of the types of the chemical reaction. With the help of the types of the, as you know, there are 4 types of the chemical reaction. There are 4 types of the chemical reaction. First type, what type of the chemical? I will tell you one by one. That I can count you. That one is the combination reaction. Second one is the dissociation reaction. Third one is the displacement reaction, and fourth one is the double displacement reaction. So first I will tell you, I will explain you the balancing of equation with the help of the combination reactions. So combination, first here, combination reaction. Combination reactions. These are combination. What do you mean by the combination reaction? When suppose there are 2 reactants A and this one is B, both will combine to each other and to make a react product, that the product of the name of the product will be AB. This is a combination reaction. Such type of reactions are called combination reaction. Now I will tell you about the different example of the combination reaction to make you understand. So here, suppose, as I told, suppose here, this is one is carbon. Suppose I take here that this is the carbon. This is carbon, and this carbon is heated in the presence of oxygen, then CO2 will be formed. C plus. So this is the balanced equation. 1 carbon, 2 oxygen, 1. This is the simple, very simple oxygen. In this same way, suppose here you take sulfur in the presence of O2, then this will be SO2. But here, suppose hydrogen and oxygen are heated or reacts with each other, then what will be happen? here you will see that H2O will be formed when hydrogen and oxygen are reacted with each other, and then H2O will be formed. Now it is here it is both the equations are balanced equation, but here you see here hydrogen 2, this is hydrogen 2, this oxygen is 1, here oxygen is 1. So how will you can say here, you can multiply this with 2H2O, the oxygen here 2, then you can write here 2H2O. Again here there are 4 hydrogens, so you can write here 2H2. So 2H2 plus O2 is equal to or 2H2O. In this same manner, suppose this is N, nitrogen, and this is hydrogen. You can write here, suppose you will write here N2 plus S2 is equal to NS3. Ammonia will be formed. So again, here nitrogen, there are 2 nitrogens, so you can multiply with this 2 to nitrogen. So how many hydrogens are there? There are 6 atoms of hydrogen atom, 3 into 6, here 2. So you can multiply this 3 and 2. N2 plus 3S2 is equal to 2NS3. These types of the reactions are called as combination reaction. I am giving you more and more example to make you understand. Suppose take an example. When aluminium is heated in presence of nitrogen. When aluminium is heated in presence of nitrogen, what will be happen? So combine this both the equation. You will write here. What will we write here? ANN. And here, when magnesium is treated with nitrogen, here I will write. Suppose here this is magnesium nitrate. But now I have to correct the formula of both the compounds ALN and MgN. ALN is right because the valency of the aluminium is ALN and here the nitrogen is 3. But here in this case, the formula of the magnesium nitride will be Mg22 and 222. So here Mg3N2. This is the formula. Mg3N2. So here, how will you know? You will balance the equation that there are 3 Mg, there are 3 Mg. This is 3 Mg and this is N2, so Mg. Mg3N2, this is the balanced equation. Now here, in this case, here N2, so there are 2 nitrogen, so 2 ALN. So here you will write, so 2 ALN plus N2 is equal to 2 ALN, aluminium nitride, and 3 Mg plus N2 is equal to magnesium nitride. Now take any example like this. This is also a combination reactions that I will tell you. Suppose you are taking Fe. Suppose take the Fe. As you know, there are 2 types of Fe. I have told you there are Fe and Fe. So when Fe is treated with or heated in the presence of oxygen, then FeO plus Fe2O3 will be formed. When this is Fe double positive and Fe oxide, and this is Fe triple positive, then this will be. So now how will you balance this equation? Come to the partial method. Suppose here when you Fe, this is Fe, O2, the formation of the FeO, this is FeO. Now balance this equation. There are 2 oxygen, now you can 2 FeO and 2 Fe. When Fe again, Fe plus O2, now what will you form? Fe2O3. Fe2O3 will form in this way. So here, how will you balance this equation? So here again, I am telling you, sir, how will you Fe2, there are 3 oxygen there. So you can write here 3O2. 6 atom and 2 Fe. 2 into 3, 6 oxygen and 3 O2, 6 oxygen. Oxygen is balanced, so here are 4 Fe. Here are 4 Fe. So here, in this way, you can write here the total equation, balanced equation, right here, 6 Fe. 6 Fe plus 4 O2 and 2 FeO. 2 FeO plus 2 Fe2O3. 2 Fe2O3. And this 6 Fe plus 4 O2 is equal to 2 FeO plus 2 FeO. In partial method, we have balanced this equation like 6 Fe plus 4 O2, but here we have we can take 2 common from this equation. You can take here, so here 3 Fe. You can write here 3 Fe plus 2 O2 is equal to FeO plus Fe2O3. Fe2. So the balance equation is here, this one. This. So when you found in the partial method that we have multiplied some extra number, so you can take this common. You can take it from here common. This 3 Fe, 2 O2, 4 FeO plus Fe2O3. So in this way, 2 O2, this Fe, 3 Fe plus 2 O2 is equal to FeO plus 3 O2. This Fe, Fe2O3, 3 O2, 3 plus 1, 4 and 2 O2. This is the method. How will you balance all the equation? Now I am giving you an example, more example about this. I am taking the example of the combination of the phosphorus. When phosphorus is heated in the presence of, when phosphorus is burned in the presence of oxygen. When phosphorus is burned in the presence of P plus O2, P2O5. Two types of the oxide will be formed, P2O3. P2O5 and P2O3 will be formed in this equation. So how will you write here? You write here P plus O2. So here P plus O2, what will you want to? P2O3. P2O3. So here, how will you balance this equation? There are 3 oxygen, here are 2 oxygen. As I told you in my previous equation, there are 3. So multiply this oxygen with 3. 3 into 6 and 2 into 3. 3. So here 6 atom of oxygen. Here are also 6 atom of oxygen. So here again, so what? There are 2p, 3p, 2p. So p2 into 2p, 4p. So you write here p4. 4p. P4 because the phosphorus is a tetraatomic molecule. Phosphorus, there are 4 atoms in the molecule of a phosphorus. So you can write here P4 plus 3O2 is equal to 2P2O3. In the same manner, when you will find P or 5O2, so here P plus O2 phosphorus pentoxide. Phosphorus pentoxide. So here are 5 oxygen, here are 2. So you will multiply this oxygen with 5. 5 into 2, 10 oxygen. Here are 2 into 5, 10 oxygen are there in both types. In the reactants, there are 10 atoms of oxygen, and in the products, there are 10 atoms of oxygen. Again, P2O, P4. So you can write here P4. Again, you will write here 2P4 plus 8O2, then 2P2O3 plus 2P2O5. Both two types of the phosphorus oxide will be formed, phosphorus trioxide and phosphorus pentoxide. So here again, as I told you, so here 2 to 8, you can take 2 common from this equation. So the final equation will be P4 plus 4O2 is equal to P2O3 plus P2O5. This is the equation. 5 and 3, 8 oxygen, 4 into 2 oxygen. So this is the way how will you balance the equation. These are the, I am telling with the help of the combination reaction. Again I am taking some more example about the combination to make you understand. That is when the calcium oxide is treated with water. This is calcium oxide and H2O. So H2O, this will form calcium hydroxide. Calcium hydroxide. So calcium hydroxide. So take this example in this way. Suppose this is a calcium oxide and this one is HOH. So try to understand this. You can write this equation to learn about the calcium. This O will combine this OH. So this calcium will join with both the OH. Here OH, here OH. You can write it like this, calcium hydroxide. So CaO plus H2 is equal to 2H2. In the same way, suppose you are taking here NH3. NH3 plus HCl. NH3, both will combine with each other and to form the NH4Cl. Suppose I ask you, give me an example to when two gases react with each other to form a solid. When two gases react with each other to form a solid, these both are the gases. This is NH3 gas, this HCl is gas, and this is the solid. This is the example. The two gases react with each other to form the solid. In the same way, you can write here H2O when CO2, it is H2O plus CO2 when carbon dioxide when carbon dioxide is passed through the H2O, the carbonic acid will be formed. H2CO3, and it again it can dissociate into H2O plus CO2 on heating, and it is on cold. It is on cold. Heat low temperature H2O when CO2 is passed through the cold water, then H2CO, carbonic acid will fall. When it is heated, again it will dissociate into H2O plus CO2. In the same manner, when H2O plus SO2, you can write here H2SO3. H2 is 3, and when it is heated, so it is again dissociating to H2O plus SO2. This is the type. So I hope that you have understood about the balancing of the equation. Today I told you about the format or the skeleton of the chemical equation. Second one, I told you about the ways how will you balance. The one is heat and time method, and second one is partial method. Again, to make you understand, I have taken the example of the combination reaction. I have told you so many examples of the combination reaction that will help you to learn the chemistry, to know about the equations of the chemistry. And this is the combination COH2O, H2O, so on. So I think that you have understood about the balancing of the equation. So please like this video. This video is very helpful to learn the chemistry. If you learn the balancing of the equation or the language of the chemistry, the chemistry will be easy for you. The chemistry will be easy for you. So please pass this to tell your other friends about this video to gain some help to learn the chemistry. Thank you very much.